Right, so now we're going to be moving on to the next chapter, which is forces and acceleration. So you guys might have known Newton's law, three laws, right? And the most important law we're going to be looking at is the second law, where it has that the resultant force is equal to mass times acceleration. So I've written it out for you guys here. So resultant force meaning that, well, there could be more than one force, right, acting on the particle. So the sum of all these forces is equal to the mass times acceleration. And that's what we're going to be using to solve these different types of questions. Now, when we're doing this, we need to be aware of all the different types of forces which could be acting on the particle. So I've just drawn out a couple for you on this particular particle here. So important things to note is, first things first, W. This W stands for the weight, and it's just mass times G. G being the value we looked at before, 9.8. Now, mass itself is not a force, so to convert it into a force, we need to change it into weight, so it has to be mg like this. Next force we need to be aware of is this R value here, which stands for the reaction force, which comes from the floor pushing back upwards. So this force is always there when a particle is in contact with another surface. Other values will be this, other forces will be this one here, this T, which stands for tension. So if this particle is pulled by a certain rope, then we call it a tension force. If it is pushed by a certain force, we call it a thrust force, and is pushing behind it. And finally, this Fr, this stands for friction, because in most cases there is a friction in the world, right, when you're pulling something, so that's what we call Fr. So these are just some of the forces that you guys need to be aware of when trying to solve these types of questions. Right, so let's look at this example here. So we're trying to find these acceleration values here, A. Okay, so for part A, we're going to be looking at forces. Now what we're going to do is we're going to look at something called resolving. And this is written like resolving in a certain direction. Now this direction is determines which way the positive direction is, and the main way you should be thinking about is which way is the positive velocity going, which way is it moving. Well, if it's accelerating downwards, then we can say resolving downwards like here, and downwards is therefore be now our positive direction, which is very important. So using Newton's second law, resultant force is ma, we have to look at all the forces acting on this particular particle. We have two forces, we have 8 and 2g newtons. Now force is a vector, so the direction matters a lot, and we said that going downwards is positive, so 2g going downwards will therefore be a positive 2g. 8 newtons is going upwards, which is the opposite direction, it's going to be minus 8 is equal to 2 times a. Okay, so it's very important that you get the correct directions right. If you were to solve this, then a, you should get a value of 5.3 meters per second squared. Same thing for b. Now acceleration is now moving upwards, right? So let's say resolving upwards now. So upwards is now positive direction, so F is ma. Looking at the forces, where there's 100 newtons going upwards, that's positive 100, minus 8g going downwards, is going to be equal to the mass, which is 8 times acceleration. So acceleration will therefore be 3 meters per second squared. So as long as you get the correct, you set initial positive direction and follow that positive direction, then you can solve using this Newton's second law. Right, a force of 10 newtons acts upon a particle of mass 3 kilograms, causing it to accelerate 2 meters per second along a rough horizontal plane. Calculate the value of the force due to friction. So you need to start becoming very comfortable with drawing these questions out so you can visualize it. So it's a horizontal plane, so it's on the horizontal table. A force of 10 newtons is acting on a particle of 3 kilograms, so the weight acting downwards will be 3g, because we're looking for weight, right? Mass times g. A force of 10 newtons is pulling it, so we can have 10 newtons going like this, and accelerating at 2, so acceleration we show by a double arrow like this, so 2 meters per second squared. And then it's got a rough horizontal plane, so there's going to be friction on the other way, so let's call this one Fr like this. And even though we're not going to be using it for now, we have to create the reaction force like so. So this will be the force diagram for this certain example. Now trying to find this Fr, so what we have to do is resolve in the horizontal direction. I'm going to go right as positive, because it's accelerating right. F is ma. So forces we have is 10 minus the friction is equal to mass, which is 3 times a. A is going to be this 2, right? So it's 3 times 2. Which then I can rearrange to get friction as going to be equal to 4 newtons like so. So with this diagram, I can see very clearly the equation that I'm going to be using and the values of each possible force. Okay, let's try another one. So a trolley of mass 50 kilograms is pulled from rest in a straight line along a horizontal path by means of a horizontal rope attached to its front. So once again, it's a horizontal plane. The weight of the trolley is now 50 kilograms, so it's going to be 50g. It's going to be pulled along like this, okay, with some this is a pulling force, we have to call it T for tension, and the trolley accelerates at the constant rate of 2 seconds. After 2 seconds, its speed is 1 meter per second squared. So we don't know its acceleration, so let's call it A. as it moves, the trolley experiences a resistance to motion of magnitude 20 newtons. So it's going to go right, so it's going to resistance is going to go left with 20 newtons like this, and we can draw the reaction force going upwards like this. Part A, find the acceleration of the trolley. So we're told that it's in 2 seconds, its speed is 1 meter per second. So in this case, what we're going to be using is the Suvat equations, because we can use them in connection with this force equation. So we know that S U V A T, U initially was at rest, final velocity is 1, time is 2, so I'm trying to find this. So I can use the equation V is U plus AT, 0 is equal to, so 1 is equal to 0 plus 2 times A, so therefore A is going to be 0.5 meters per second squared. Right, B, find the tension in the rope. So in this case, now we're going to be using the forced equation. So resolving right, this is accelerating right, F is ma, we're going to have T minus 20 is equal to 50 times 0.5. So T, we're going to get a value of 45 newtons, like so. So we're using the Suvat equations with the force equation to work out each different value. And this Newton's second law doesn't only work in one direction, it can also work in 2 directions at the same time, so in vector form. So if a particle of mass 8 kilograms is at rest, it is acted on by 3 forces F1, 2, 3. Find the magnitude and direction of the acceleration of the particle a meter per second squared. So in this case, we don't have to resolve, we just have to do F is ma straight away. So F is going to be the sum of all the forces, right? The resultant force, which just means it's going to be the sum of F1 plus F2 plus F3. So writing in column vector form, we're going to have 3 minus 1 plus 2 minus 5 plus minus 1, 0. That's the resultant force on the left-hand side. It's equal to the mass, which is 8 times A. And so we should get that A is going to be 1 over 2 and 3 over 4, like this. It says find the magnitude and direction. So this is technically just acceleration in a vector form. So the magnitude of A, so it's going to be like this. So it's the square root of 1 over 2 squared plus 3 over 4 squared, which gives us root 13 over 4 meters per second squared. That's the magnitude of the acceleration. And the direction, okay? So if I was to draw a certain graph, then this here acceleration is going to be a half, and then 3 over 4, like this. And it's going to be moving in this certain direction here, right? That's the acceleration. So we need to know the angle. So let's work out this angle here. Let's call this one theta. So as you can see here, I can draw a right angle triangle, and therefore I can say that tan theta is going to be the y, in this case 3 over 4, over the x, which is going to be a half, and theta we get a value of 56.3 degrees. So it's acting at an angle of 56.3 degrees above the positive x-axis. Right, B, find the time taken for the particle to travel 20 meters. As I said, you can use the Suvat equations with this force equation because they are related to each other. So we're trying to find S U V A T. We know A with the magnitude is root 13 over 4. We're also trying to find at the distance 20, so S is 20, U initially was 0. So we're trying to find the time taken. So once again, I can do S is UT plus half AT squared. So we're going to have 20 is equal to 0 times T plus half times root 13 over 4 times T squared. And T, we get a value of 6.7 seconds. Right, final example. So we have 2 forces, 2I plus 3J and PI plus QJ act on a particle P. The resultant of the 2 forces is R, and given that R acts in a direction which is parallel to minus I plus 4J, show this equation here. Right, first things first, let's work out what R is. So R is the sum of each force, so it's going to be 2I plus 3J plus PI plus QJ, which is going to be equal to 2 plus PI plus 3 plus QJ. So that's the resultant force R. Now it says that the R acts in the direction which is parallel to the vector minus I plus 4J. So if I was to sketch the vector minus I plus 4J, it's minus 1, 4, so that vector is going to be moving in this direction here. Now for parallel, we know that the gradient has to be equal to the same. So the gradient of this vector here has to be equal to the gradient of our R vector here. That's how we're going to equate them together. So the gradient of this vector minus I plus 4J is just J over I, so 4 over minus 1. And that's equal to J over I of R. So it's 3 plus Q over 2 plus P. So that's how we've equated them together. Now just rearranging, so 8 plus 4P is equal to minus 3 minus Q. And we're going to get 4P plus Q is plus 11 is equal to 0.